Hello, Algebra 1B students. Welcome to part 1 of lesson 9.6 on the quadratic formula. We have one more way of solving quadratic equations that we need to learn. This one it involves the most work on our calculator probably, because we'll be squaring things, subtracting things, square rooting answers, and things of that nature. But the quadratic formula is very nice because it allows us to find the solutions of any quadratic equation. Okay, so we looked previously at completing the square as a way to solve when we can't factor. The quadratic formula is a way to solve a quadratic equation when completing the square potentially involves decimals, or our a value is more than 1 and we don't want to divide and deal with those decimals in completing the square. So we will use the quadratic formula in that situation. Now the quadratic formula is something that you should all remember from today onward for the rest of your lives. It's one of the most common formulas in mathematics. And it's right here. It says this. It says if you have a quadratic equation with an a value in front of the x squared, a b value in front of the x, and a c value, all equal to 0, obviously, we do need to start putting them back in this standard form, unlike when we complete the square. The answers or the solutions, your x answers, are equal to this. Negative b plus or minus the square root of b squared minus 4ac all over 2a, all divided by 2 times a. Okay, there's a song for that, and I'll sing it for you in class if you ask, but I'm not going to do it here for the whole YouTube world to hear. So suppose we have this equation. The first thing we need to identify when using the quadratic formula is what is my a value, my b value, and my c value. In this case, a is equal to 2, b is equal to 3, and c is equal to a negative 5 or a minus 5. Okay? And then we just plug those 3 numbers into this formula here, wherever it says a, b, and c. So it would become negative 3 plus or minus the square root of all this stuff under the square root. 3 squared minus 4 times 2 times negative 5. Once we do the plussing and minusing on the top, we divide everything by 2 times 2, which in this case would be 4. Okay, now, oftentimes, these answers will not come out to be perfectly whole numbers. Sometimes they will. I believe in this case they will, but let's check it out and see. This is problem 1 on page 583 if you want to follow along in your book of what I'm doing up here. They want me to solve the equation x squared minus 8 is equal to 2x. The first thing I notice is this is not equal to 0, which is going to be a big problem for me. So I'll take away 2x from both sides and rewrite it in that form. X squared minus 2x minus 8 is equal to 0. So now I have it in a formula where I can solve. My a value is equal to 1, my b value is equal to a minus 2, and my c value is equal to a minus 8. Okay. So if I set up my quadratic equation in this case, my x answers are going to equal the opposite of my b value, negative 2, plus or minus the square root of negative 2 squared minus 4 times a, which is 1, times c, which is a negative 8. Once I've done that, I will divide everything by 2 times 1, which in this case will just be 2. Okay, now negative 2 is just a positive 2. I flip it back. So if your b value is negative, you'll flip it back to positive in the front here. Plus or minus the square root of, now I'll do some of this math in here. Negative 2 squared is negative 2 times negative 2. That's 4. Minus 4 times 1 is just 4 times a negative 8 is negative 32. So I have 4 minus negative 32, but that's like plus positive 32. And then I will divide everything by, as I said, 2 times 1 is equal to 2. Now, if I go up here for just a second and deal with this square root, I have the square root of 4 plus 32, because it was minus a negative, which is the square root of 36. Now, that should equal positive or negative 6, if we remember our rule about square rooting things. However, because I have this plus or minus here, I don't have to worry about the plus or minus here. Okay, so my answers are just 2 plus or minus 6, all divided by 2. And I'll give myself a little bit of more room here before we get down to your question. Go that down a little further. Okay, so I'm at this point here. This is what x is equal to. X equals 2 plus or minus 6, all divided by 2. So one option for me is x equals 2 plus 6 divided by 2. 2 plus 6 obviously is 8. 8 divided by 2 is equal to 4. That's one option. The other option is x equals 2 minus 6, all divided by 2. 2 minus 6 is equal to negative 4, divided by 2 will give me a negative 2. My two answers are x equals negative 2, or x equals positive 4. Positive 4, negative 2, and that came from my quadratic equation. Okay? So it looks complicated at the beginning. Your main job in solving these problems is to make it simpler. To do the squaring here, right? To do the multiplying here, to do the negative stuff here. And once you get that simplified down, it should look nicer and nicer and nicer. Now, it's quite possible that this number here will not be a whole number. Right? We got lucky because it said 36. In many examples in your homework, it will not be so nice. It may end up being 6.34, 6.73842. And in that case, you can just round to 2 decimal places. So 2 decimal places if you need to. I would like you to try one. Here, down at number 1, which is right at the very bottom of page 583, I would like you to find the solutions to this equation here. X squared minus 4x equals 21. Move that 21 over first, obviously, so that it's equal to 0, and then solve using your quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Pause the video, try that one with your quadratic formula, come on back, and I will show you what it should end up being. Okay, I am going to skip through all of the math. I will show you the setup to it. X should equal positive 4 because it's negative 4, plus or minus the square root of negative 4 squared, minus 4 times 1 times negative 21 when you move it over to the other side, all divided by 2 again. And we should end up with x equals negative 3 or x equals 7. Okay, if you did not get x equals negative 3 or x equals 7, please make a note to ask me in class tomorrow so that we can clear up whatever the mathematical issue was that you had with that problem. Okay? Now, we have learned in this chapter a lot of ways to solve quadratic equations, going all the way back to graphing very early on. We graphed quadratic equations and looked at where they cross the x-axis. We did it by finding square roots. We did it by factoring before our quiz. And then since the quiz, we've done completing the square and the quadratic formula. Okay, so here's all of our methods. Graphing, square roots, factoring, completing the square and quadratic formula. You will notice that I have crossed out graphing because if I am asking you to find the solutions to a quadratic equation or solve one for x, graphing is probably going to be the worst option for you in many cases. Because anytime it's easy to graph one, it's also very, very easy to find the square roots, to just do it algebraically, moving things over, dividing and taking the square root. Okay? So here's your four options. Here, 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 and here. And here's when to use them. We want to use square roots if the equation has no x term. We'll see an example of that in a second. We want to use factoring if you can easily factor the equation. So that's always our first check. This one we want to check first. Can I factor this? Usually we want our a value to equal 0 if we're going to do factoring. Or sorry, not a equals 0. What am I talking about? A equals 1. We want a to equal 1, meaning it's just 1x squared. No numbers in front of our x squared. Same thing with completing the square. We would like our a to be equal to 1. So use it if the coefficient of x is 1, but we cannot factor. We use completing the square when we have a nice coefficient of x squared, but we cannot easily factor because of our b and c values don't match up well. And then quadratic formula, use if the equation cannot be factored at all, or if you cannot factor it easily, or you just don't want to, and you want to use that quadratic formula if you like the math. Part of your homework, or part of your practice problems is going to be problems that look like this. Which method, or methods, would you or could you choose to solve each equation? Justify your reasoning. If you look here at letter A has a coefficient of x squared of 1, right? If it's not there, we assume it's a 1. So I should be thinking complete the square or factor. Let's check and see if you can factor it. Let's see, multiply to be 12. Both negatives that have a difference of 8. How about x minus 6 and x minus 2? I would say factoring, because I just did it. Very nice. Letter B. I see 169x squared. I see a 36. I do not see an x value. There's no b value here, nothing with an x. So we should think, find square roots. We would do that by dividing by 169, and then take the square root of both sides and get plus and minus answers. Square roots because there's no b value there. No b value. No x term, right? And then this last one, we see a 5x squared in the front. Immediately, I hate that. I'm not going to want to factor. I'm probably not going to want to complete the square because I'd end up with 13/5 as my b value. Just doesn't seem very fun. So here I would use the quadratic formula, quad form, because of this a value being equal to 5. Okay. If you have any questions about when you should use what, please ask me in class tomorrow. Otherwise, that's all I have for you. We are done figuring out ways to solve a quadratic equation. So congratulations on that. You have learned all the ways that we will learn in this class to solve a quadratic equation. That's all I have for you tonight. Have a wonderful night.